Coming up on this episode of the IoT Inc Business Show.
So how much domain expertise do I have? What am I building? And then where do I outsource the other pieces? If I do have domain expertise in the type of things I'm sensing, then of course I'm probably going to make the decision in terms of the sensors, the type of network, and then I'm going to look at other people to do the other portions of it, connection of it, the cloud connection of it, the reporting and all of those types of things.
It takes a lot of work, behind the scenes work, to establish a successful connection between sensor and IoT platform. While it's possible to find off-the-shelf sensor subsystems for common use cases, often custom hardware and software design is needed to make the system/connected product or asset operate as desired. In this episode of the IoT Inc Business Show, I get into it with Mark Wright about the who and the what behind the scenes that are needed to make it all happen.
All this and more on this episode of the IoT Inc Business Show. The people, the business, and the technology of the next generation internet. This is the IoT Inc Business Show. And now, here's your host, Bruce Sinclair.
Hello and welcome to the IoT Inc Business Show. This show is made possible by sales of my book, IoT Inc, published by McGraw-Hill, and the IoT Inc Certified IoT Professional, or ICIP, online training and certification program. Become a certified IoT professional by completing the program's 3 courses: ICIP Technology, ICIP Business, and ICIP Strategy and Digital Transformation. Details of which can be found at www.iot-inc.com. That's www.iot-inc.com.
With me today on episode 2 is Mark Wright. Mark is Director of Product Management at Ayla Networks. He has over 20 years of embedded experience spanning the military, industrial, and the consumer product markets. He has been involved in embedded IoT for 8 years and has deployment experience in power, transportation, consumer, and home automation. Given his hands-on experience, I thought Mark would be a great guest to walk us through a bit of the tech and a lot of the business for making a connected product. Mark, good to speak with you. Thanks for coming on the show.
Hello, Bruce. Good to speak with you too. Thank you.
So what have you been busy with lately?
Busy with cloud computing, lots of interest there, and lots of work.
Good. Well, why don't we start by you telling our listeners a little bit about yourself and your background in IoT.
Sure. So I started in IoT. I've been in networking for quite some time and embedded electronics and semiconductors for, as you mentioned, right, more than 20 years. But IoT about 8 years ago, and about 8 years ago, IoT was really just connecting to a LAN, right?
Yeah, early.
And, accessing devices through a web page. And pretty soon after that was, doing a local application on a mobile device, and that became IoT. Mm-hmm. And now it's progressed to all of those two, plus extra connectivity through the cloud.
Yeah, and the cloud. I mean, this is interesting because sometimes people, I guess there is a big discussion as to where is the computing happening. Are you seeing it all happening in the cloud, or do you see it being distributed?
There are several models, and it really depends on what's being required, what's being done, and in a way, the type of platform that's chosen. The value of it occurring in the cloud is agility. Right. So if you do it in the end node, those end nodes or the gateway that controls those end nodes, those are already fielded. So you start running into a problem of if you put too much intelligence there, you've locked yourself down. By moving that into the cloud, you keep yourself flexible in the ability to change it and modify as you learn from data that's coming in.
Right. Okay, well, we'll get into that a little bit, but I think, the place I'd like to start is we've got a product, and it's not connected. So how does an IoT platform connect, two sensors in a product? I mean, what's the connection?
Well, now there's various definitions for that term connection, right? So right at the beginning, if we've got sensors of some type of on some type of a product or some type of a system, we've got to get right to that. So if we're going to go wireless, right, there's going to be some kind of a media layer, and at that point, we can decide whether it's Wi-Fi, whether it's 802.15.4, Zigbee, proprietary, sub-gigahertz. There's all these lower layer communications that are available for us, even on the wireless side, right? And then from there, again, depending on that decision, some of those the network protocol layers decisions have been made for us, and in other cases, the protocols are ours to define if it's proprietary, right? And then we need to connect up in through an application, and then to the product application of what this thing is, and then also from there move that data to the network and into the cloud, and potentially provide a mechanism for data to come back to that device.
So there's a number of layers. One quick question I have is on the media layer. What percentage are you seeing wireless, and is there any wired that's happening? I know M2M, if you want to go back a little ways, I mean, a lot of that was wired, but what are you seeing out there in the field today?
Well, specifically because we're talking about sensors, and sensors, there's been a lot of interest in wireless, just from the perspective of, right, saving on installation costs. So we're generally in a sensor type deployment, we're going to have many, right? We're having tens, we're having hundreds, we may have thousands. And to wire something like that, yes, you can get, something that's potentially pre-configured, but otherwise, wireless is the way to go.
Okay. And with the wireless, obviously comes other issues such as, powering them and so forth, but I guess that's for another discussion. Now we're on the network protocol layers. You're mentioning proprietary and standard based. There's sort of a holy war there. I mean, I firmly stand on the standards based protocols, but I'd be interested, real world. What's the real world happening out there? Are we doing still a lot of the proprietary protocols like the Zigbees, the Z-Waves, and so forth, or are you seeing a movement to the standardization of these networking protocols?
Bruce, you bring up a couple of very good points there, even on your previous one. So when we're deciding on the type of fielding, there are a number of decisions that need to be made, right? You did mention power earlier too, and then also from the protocol that we get to choose, right? And really what happens is we should go towards a standards-based deployment because of all the learning, all of the value that we get, and the constant work that's there. But having said that, there are a number of choices. The whole reason there are a lot of these different choices for us is because in the wireless field, right, there are protocols that have strengths in different areas. And so that, depending on what the system requirement is, that will lead us to a particular type of technology. And then we can make a decision on, is there a reason for us to go proprietary, right? Is there something a little bit more that we need within the capability of that technology? Maybe we need more battery life and we can trade off bandwidth. Or, we need some very specific type of protocol, or we're going to customize some other feature, and so we're going to go. And so those are some of the reasons. But generally, you want to stay, unless you need to do that, you want to stay within the standard.
Yeah, but you do bring up a good point. I mean, we don't want to be standardized for the sake of standardization. We want to be standardized because it's going to help our business. And I think the point that you're bringing up is an important one. And to me, it just says, well, the standards or the consortiums or the associations haven't if we're not choosing them, then that means they haven't done their job well enough, and meaning that they're not suitable for business purposes, and we're selecting other ones. But that's a good point. I mean, primary, first most, it has to support the business that you're trying to support.
Right. And to be clear, there are many that are there. And as an example, if we pick Wi-Fi, if we pick Zigbee, there's no particular need to customize there, but we could go into a sub-gigahertz type technology and create our own proprietary for other reasons.
Yeah, well, in my book, I mean, I would consider Zigbee proprietary too, but I guess it depends on how you kind of look at that angle. Let's move on a little bit and talk about sensors. So the selection of sensors is obviously a very important step, and this is a scenario where we have a product and we want to, or an asset, or I guess an environment, and we're now selecting the sensors. So how does this usually play out? I mean, what comes first, the sensor or the platform, or I mean, what do you see as, because I would think anyway that selecting that sensor, because that sensor is going to sense the data information that is important to you and ultimately will create the value. So I would suspect that the selection of that sensor would be a super important step. But how does this normally play out? Is it manufacturing based? Is it platform based? What's your experience there?
You are hitting on the right points, and the key here is that there were several points. So really, the decision needs to be made at a system level in terms of what do we really want our system to do, right? Okay. Why is it we're trying to sense some particular thing, right? Is it, example, are we putting sensors on a bridge to detect weaknesses on that bridge? Mm-hmm. So we have to determine what's the overall system. From that system, then we can split into, okay, what are the type of sensors that we need for the things we want to measure? But also, we talked even earlier. Again, we talked about the whole issue of power, right? Are they battery operated?
Sure.
Or or is it very low power? Or is power not an issue because it's going to be wired? So those types of decisions then come into it, and then of course, right? What type of things? What type of measurements are we doing? And so, what kind of sensors are available to do that? How big is this system going to be? So, as you mentioned, manufacturability, right? Is it a custom thing that can be done in small lots, or is this a big undertaking? And so, we need to have some manufacturing optimization. But even also from a platform perspective and from cloud platform, what do we want to do with the data that's coming from these sensors? And that will also create some decision criteria for from the product perspective, from the platform perspective, and then these can come together to determine, okay, how do we actually field this thing?
So what about the fielding of this thing? And I guess that's where I have a gap in my knowledge. Is okay, we've come up with the criteria that we need. Then do we go to some magic website and find all these sensors? Do we go to our SI and they find them for us? Do we go to our partner, like our platform partner, like yourselves, and you guys find them? Like how does that play out? Like how do you find them once you have all the criteria kind of nailed down?
This is part of nailing down that criteria too. That's going to come down to how specialized those sensors are.
Okay.
Right? Are they chemical type sensors? And then there's other decisions that need to be made in terms of what are the ongoing requirements for this product once we field it, right? What are the ongoing costs and the like? There's going to be maintenance. There may be maintenance needs, things of that nature. So, right, if they are very simple, we can go onto the web, we can search, we can get people to do that for us. Generally, the product manufacturer can do that search based on the criteria that's given to them.
And when you say the product manufacturer, which product are you referring to?
So if you're going to like an OEM that's going to do this, right? So the requirements can be provided that basically I want something that's going to be. So let's take a concrete example, right? So we may be we're a large motor manufacturer, and we want to create a network of sensors that's going to go into a manufacturing line to measure these motors, the health of these motors, right? So we have a certain criteria, certain vibration requirement, and so that can be given to an OEM, and now they can look at, okay, what are the different sensors that are available, right? Is it going to be, are there MEMS sensors that I can use? Are there other types? What's my cost? What's my life cycle? What's the data resolution I require? And so those decisions then can then be made.
Okay, and in this case, the OEM they're taking which role? In the case of in let's say the case of the engine example, the OEM, are they pulling it all together like a system integrator, or are they just OEMing or sourcing the parts and someone else puts it together, or what do you think?
It can be either. It depends on who's requesting this. So the level of expertise that's available in the company that's creating this product definition. Right? So if they normally build electronic systems that have the communication side but not the very lowest end data collection, they may give this to an OEM that basically builds a sensor. We talked about the networking earlier, that lower level, connectivity to the gateway, and then this company will take over. So that's actually an interesting point, because that comes in on this decision quite a number of times, right? How much of this should be done by the company that's looking for this product?
Yeah, no, that is interesting, and I think you bring up the right point in the sense of it just depends on how much in-house knowledge you have. Now, obviously, you'll have the domain-specific in-house knowledge, so I would assume you'll be able to define, or the the company that's connecting their product will be able to define what exactly they're looking for, but they may have to go outside for help in your example on the communication side, and they may know what they're trying to measure, but they may not know how to do it or how to network it. And in that case, you're saying they would go to a sensor OEM and for that help. Is that right?
No, not so much as a sensor OEM, and I may have actually even used the wrong term. So we would go to a design house that would create that portion of the design, right? So they would take our requirements. It really comes to what you just mentioned, right? The domain expertise of the manufacturer, right? So how much domain expertise do I have? What am I building? And then where do I outsource the other pieces? So, right. So if I do have domain expertise in the type of things I'm sensing, then of course I'm probably going to make the decision in terms of the sensors, the type of network, right? And then I'm going to look at other people to do the other portions of it, the connection of it, the cloud connection of it, the reporting, and all of those types of things.
Okay, and I like that. I mean, what you said is, first of all, you're defining it properly. This is a product. It's if we look at it as a connected product, then it is a product that's separate from the unconnected product. And then what you're saying is, and I think OEM maybe there's different terminology, but what you're saying is you may need some network design firm, or maybe, and generally I would think that would be in a VAR or a system integrator would have these type of skill sets, but you could also get them independent too, where they would then take the sensors that you need and then basically design that network for you. And obviously you guys would come in, or the IoT platform would come in as well as part of that. Well, I don't know. Are you involved? Are you involved in the sensor network stage of things, or is it really no? You just take the data from there.
We are involved at the so we would be involved in the systems definition stage. Okay. And so taking a wider view, some of the items we mentioned here, right? So we would use a potential company would have this idea, this concept of what they wanted to build. They would create this, would have an architectural discussion, And let's, for the sake of argument, say that they don't have the capability of actually building the sensor network out. Mm-hmm. So they would get a design house. A design house would get involved. We would get involved in terms of, right, what's the overall picture, what's the overall data flow from the product into the cloud to the, maybe if it was, in this case we were talking about those motors, so this is going to go into an industrial application. There's some kind of a plant manager that's probably wanting to monitor all this. There may also be a corporate manager that's monitoring the various different buildings that they've got and all the lines that they've got there. So what are all these data flows, all the reporting requirements? What is that type of data? How much data is coming up to the cloud? Right. So there's that architectural view that's done. There would be a systems integrator involved to put all the pieces together. So the SI wouldn't necessarily create anything. They won't necessarily do any hardware design. So that's probably that design house.
Okay.
We would provide the plumbing, if you will. Ayla would provide the plumbing, which is the putting that data onto the network securely, getting it up to the cloud, providing libraries for people to use that data, both for very rich mobile apps, and then also a library on the product itself to be used to determine, how much data do I send up, when do I send it up, maybe I'm getting some data back, right? So maybe there's a light on this little sensor unit, and when the analytics are being done in the cloud, this light can turn red. So when a technician is sent to the line only when required because a certain motor is misbehaving, it's vibrating too much, they can easily find it because the light's flashing, right?
Okay.
So data's coming back. So that all of that would be architected, and then the SI would be responsible for putting all those pieces together. So they would take all this plumbing, all the pieces, if you will, of the puzzle, and then they would put it together and stitch it, and then we'd be ready for testing.
Yeah, so they would take the sensor network, the underlying platform, and then the analytic capabilities, and basically, yeah, like you said, I guess, integrate the system together.
That's right. Yeah.
I guess that makes sense. All right, I want to talk money now and talk budgeting. So the costs. What are the costs associated with sensor selection? I mean, what the business manager that's listening to this podcast now is thinking, all right, well, I've got a bit of work to do ahead of me here. I mean, I need to basically define, do a product definition. I need to understand, like you were saying, in terms of data flows and reporting requirements. But from a cost point of view, what should they be looking at? I mean, how do you budget? How do you budget? Again, I'm talking more on the sensor side, but what should they be thinking about up front when budgeting for these sensors?
This will come down to let me address that from a slightly different view, because that's almost from the pre-starting point. So they're going to, as a company with their domain expertise, they're going to look at this is what I want to do. Let me do some research and see kind of what the costs are. Right. So generally, what's going to happen is they're going to come up with a rough requirement, right, and certainly a definition of this is what we want, right? We want to be able to go onto a manufacturing line that has 100 motors, right, and then go and upwards from there, right? This is how much data it's going to be sending. It's going to be sending continuous data, or it can send data until a event has been identified, and then it's going to start collecting more data, things of this nature. So once this is defined, then they can create their budget. How much budget I have for this project, and then they could go to a design house, right?
Okay.
Say this is the type of thing I'm looking at. I want a system that's average about 100 nodes on the line, And I think, my marketing has done their research, and they feel that we can sell a system like that for, N dollars, right?
Okay.
Including monitoring, including the analytics, including the reporting, including the notifications when there's an event. So that level of work or pre-analysis needs to be done. It can also be countered though, because why are we have a sensor network? Why are we talking cloud, right? So the value, the return can also be integrated at this point up front at some level, because again, if we're talking about our example of these motors on a manufacturing line, because this data is going to the cloud, it's going somewhere remote, and analytics can be done. The counter to that is, we don't need to, whatever the service was in the past, we can automate that. So we don't need to send a truck roll every month to check these motors out. Right? We can now monitor the motors remotely. We can have machine to machine doing that monitoring. Right? Are the motors? What's been the behavior of these motors for the last year? Let's average that out, right? Or what's the manufacturer's data sheets for these motors? Let's take that and put that into our analysis. And it's only when those motors go above a certain temperature, above a certain vibration, that we then start looking at them, create an event, and send a truck roll. So now we're saving money on there, right? We're not necessarily doing a truck roll every month. We're doing a truck roll only when required. So there's a savings. There's a negative cost portion to that now to our system from our end cost to the customer, right? So that's helping us determine, what's the pricing for this item, and then that's helping us then determine, okay, what's our budget for these, for the product, for the gateway, for the end sensors.
Well, let's talk about the end sensors, because I do want to talk about the business model, holistically as well. But I wanted to ask, from a sensor point of view, is it just a matter of just finding them on a price sheet and buying them, or are there other costs that are part of this whole selection process?
That's a good question. There are costs associated with this. And let's go back to a question you asked at the beginning, which was, right, how do we feel the system? Is it distributed in the cloud? Is there more intelligence right at the node? So a sensor by itself won't do anything, right? So we may have a MEMS sensor which is doing vibration, and it's going to have some kind of a communications interface to it. Maybe it's I2C, right? Maybe it's serial, whatever, and it's got to go to some even simple microprocessor that's going to collect all this data. Right.
Right.
And then from that data, we're going to need to, if there's intelligence at the node, then that microprocessor is going to need more capability. It's going to need more internal memory on there to have the local program on it. And it's also going to need that communications module, whatever that protocol that we had decided on initially. Right. So that's adding, we can still be considered a thin client at this point, right? And we can keep costs low. Maybe we can find an integrated module where there's already a core in there. It's got the sensor. Maybe it has some wireless capability to it. But those are fairly thin, and those are actually good because it keeps our costs low. If, again, we're going to have a fielding of 100 of these on a manufacturing line, or it's a bigger manufacturing line and we have thousands of these, right, or 1,000 of these on all the motors, we want to keep that cost low, right? Okay. So then we want to move that intelligence further up. So that the first next point is some kind of a gateway. So depending on the technology we chose, all those nodes are going to talk to a gateway, and so we can put some more intelligence in the gateway. Right, but we'll still get that same type of business decision that needs to be made, right? How thick do we want to make that gateway? How much capability do we want there versus still moving the data up and into the cloud? And that's where this whole concept of agility comes in. Because the more intelligent, it's actually it's almost like a inverse pyramid, right? The more you end up sending to the cloud, in a way, the lower your costs get to fielding, because the everything that's in volume is the cost is kept lower, right? And you're moving all of this intelligence, all of this processing, which can take a lot of capability. You're moving that to the cloud, and the other value you get from that is you get this flexibility because it's there, right? So what you'd like to do is put the capability on your node. As you get closer to the end node, and actually to that end node, you want to put the capability in there where you can change its function. So you put some, we have our little microcontroller on there. We have a program that's, taking in the sensor data, maybe doing a little bit of massaging of that data before we send it up. But if we can put some over-the-air update capability on that, now we're very flexible, right? So when we program our system to send data, right, every 5 minutes, and if we see an anomaly, we start sending data every 1 minute. We program that out, we put it in the field, but 6 months in the field, we realize, man, we don't have enough visibility once there's an event. Well, we can do an OTA change now because our intelligence is in the cloud. We can do an OTA change and say, you know what, we need more granularity on an event than data every minute. We need data every 5 seconds, right? So we just put OTA update, and now that same unit can be just giving us data every 5 seconds when there's an event, when there's an anomaly, right? So, and this is all getting to the end goal, really, of being more efficient and saving us money. Because we get more clarity on what's actually going on in that motor, and then we can determine, right, this motor seems to be misbehaving at, lunchtime every day. So maybe they're just overusing it. So we can do some analysis, or this motor, has been operating, fine for the last 2 years, but now it's misbehaving at these particular times. So, with enough visibility, then we know what's going on. We know if that motor needs a bearing change or it's being misused, and the manufacturer just needs to be advised. That's what we do.
Okay. Yeah. No, I get it. And I think what you're saying is, at a high level, these costs associated with the sensors really depends on where or how beefy your sensor network is going to be. You're promoting, or I think what you're saying is, there's a lot of advantages to shifting that intelligence into the cloud, agility being one of them, and perhaps cost per data item. I don't know. I guess you could graph that being another one. So at a high level, you're saying that's kind of the first decisions you have to make is where the intelligence is going to be. How far to the end nodes will the intelligence be? Because the closer there's intelligence there, like for example, some so-called fog computing, where that's happening at the gateway, or maybe even at the sensor level, then that just means that cost is going to be a lot higher. And aside from that, I mean, it's from a customization or a maintenance, or it sounds like maybe those costs are really secondary as opposed to this overall, probably, I guess, network design. Is that fair to say?
The maintenance costs can be very significant, and those need to be taken into account, again, at that system level at the beginning.
Okay.
And they really fall into two areas. One is, what are the type of things, right? So if we're doing chemical type sensing or pH, and these sensors need to be calibrated every once in a while, that comes into play, right? How much accuracy do we need? So maybe we can take a little bit less precision, and we don't need to calibrate as much. But that's more system driven. And actual what are we trying to do? Beyond that, there's also maintenance decision in terms of that we would have made at the beginning in terms of the sensors, in terms of the system, and which was again getting back to power, right? Were these battery operated, or are they? Power is not an issue. It's already it's going to the motor that's on a line, and there's wiring that's there. We can tap off of that so they can be line powered. So those types of the decisions we made early will impact overall long-term life costs as well. The maintenance point you brought up. The other one, you got it right in terms of the node. We want to make that node as light as possible to keep the cost down. But a part of that decision, whether it's fog or whether we just need to buffer because, right, when we said we're sending data up or we're collecting data every minute unless there's an event, we don't necessarily have to be live sending that information up to the cloud.
Sure.
We can be buffering it up. And in fact, we probably, depending on how critical that data is, for very critical data, we do definitely want to buffer it up, right? We have no control over whether, there may be a storm outside, the connectivity goes down. So we want to buffer up data, and then we have to decide from a system perspective, how critical is the data by time, right? So, it's very critical to have, our shifts, the shifts are 8-hour shifts. And so it's very critical to have, maybe 12 hours worth of data on here. And then that could be at the node or that could be at the gateway. And then we download to a local server if network connection is still not there. So, memory costs on a device can get high. So we want to be careful there, but that is part of our costing criteria, what we need to look at.
Yeah, no, that makes sense, actually. I mean, it seems like it is a balance, and it seems that it is driven very much at that system design. And, to a certain extent, you're going to want to design your ideal system, but then realistically, and that'll move us into the business model a little bit, realistically, there's also going to have to be constraints on those costs. And so that's when you may have to iterate the design to kind of fit the budget, because otherwise this whole connected product may not be profitable.
That's correct. That's very correct. Yeah.
So let's talk about business models a little bit. And again, I'm interested more in the front end, but is it pretty much just a purchase and I guess a maintenance fee, or what are the business models then with the front end sensors, I guess sensor network? What are you seeing out there now from a business model point of view?
Yeah, from that perspective, once we've defined, so we've now defined what the problem is. We've defined, how we want to implement it. We've gone out to a number of design houses. Some of them are experts in that field, right? And they've given to us a couple of proposals that we're looking over, and we're analyzing those proposals in terms of which ones are going to be higher cost to field because some of them are wired. Which ones are going to be ongoing maintenance because, these ones will need a battery replaced every year. Regardless, that will be a truck roll or a technician at that site, right? And then, of course, there's also the individual component costs. So component costs can be significant. They can be up to about 50% of the price of the end item, right? But so we're looking at all of this, and we do that trade-off. And again, we also have to look at how much are we going to sell this system for, and then where are we going to make the money off of it? Are we are we selling it as hardware as a sensor network where we're just the OEM for this fog connected sensor array, and we'll work with somebody else. Somebody else will system integrate it with cloud and the like. Well, in that case, we're going to be very looking just at the cost of that hardware. But the company that's looking at the overall fielding of this, they're going to be looking at, well, what's our revenue model? Maybe we're making money on the service, right? So what we'll do is we're going to save you. We have proof here that we're going to save you maintenance costs on your motors, right? And we can do it cheaper than other people because we're monitoring it live. So the benefits we're giving you is longer life of the motors. we don't need to take your, we don't need to have personnel going through your line, when it's not required. We're really only going to send people when we have evidence of there's events, right? And so we're less disruptive, and so our overall probably the service that we're going to sell is less costly than other solutions. So we can look at that and then make a decision of these proposals that are on which one's best for us.
Who do you normally interact with in this discussion? I mean, who's driving this within the company?
So, I see. In terms of the customer, so in this case, it will be business development, but there's going to be marketing involved. There's going to be engineering involved. Right, there is. Remember, we said at the beginning. This again, it's the systems analysis that needs to be done up front. Mm-hmm. So as far as Ayla goes with the cloud, we do get involved with the architects. We do get involved with the decision makers at a business level, because what's being done is not just the hardware decision; it's the overall product decision, right? What's trying to be fielded here. Right. So, case in point, we will discuss with like a demand management company that's looking to save a building operator some significant amount of money based on their energy usage. Right? Okay. So they'll monitor demand response events that are coming in from the utilities. They will have fielded out a number of sensors in the building for temperature, for humidity, and we'll have smart connected thermostats, which are basically acting as the fog gateway, and so they'll control the environment, and so there'll be intelligence put into the heating and cooling of the building. But in a way that also allows them to be compliant to demand response contracts. And so overall, they're saving money. So at that point, we're getting involved in a company that provides that as a service, right? Mm-hmm. So they work with, at a higher level, they work with integrators that have the thermostats that are connect with us to the cloud. And then from the thermostats down, those thermostats themselves may be gateways that have an array of sensors that are talking to them, and right. So they're fielding this as a system that they're going to deliver to their end customer, which is an enterprise, right? And that enterprise may have certain numbers of campuses, and within those campuses, certain number of buildings, and really they want reporting at all of those granularities. They want reporting done at the enterprise level, at a specific campus level, and then also at a specific building level.
Yeah, and so maybe it would be helpful at this point. I mean, if you can describe Ayla, I mean, being an IoT platform, and the role that you fulfill, but in that, tell me, when are you guys brought in, and how early you brought into the process?
Sure. So Ayla is a end-to-end embedded cloud platform provider, right? You can think of us as kind of a cloud OS that's connecting the various pieces. So in order to do that, we're really a software only house, right? So our product is really just software when you come down to it. But because of the things that we talked about, of course, we've got to get involved with the manufacturer in terms of the hardware. What hardware are they going to use to connect to the cloud? So we have these sensors, all the things we talked about earlier. So that sensor decision has to be made in terms of what's the protocol, how much intelligence is going to be put on that sensor node, right? And then is that sensor going to go? Is it an IP sensor? Example, is it Wi-Fi, so it can go directly through a router to the cloud? Or is it another protocol, and then we're going through a gateway? So we get involved in those decisions. We make it easy for those things to be used. So we have, example, on the Wi-Fi modules, we work with, in all of the protocols, we work with the leading manufacturers that make the modules themselves, those wireless protocols.
Right.
And so those modules will either have our agent built into them, or there'll be a gateway design that has our agent built in. So what do I mean by an agent? So remember we talked about even if it's a thin client, there has to be some kind of an MCU.
Right. And something needs to be running on it.
Something needs to be running, taking the input from the sensor, right, and then doing something with it and sending it somewhere. So we've defined a starting from the IP termination point. So if it was Zigbee, then that would be the gateway. So at the gateway, we go to IP. We get onto the internet, and at that point, we have a very secured methodology where we send the data encrypted to the cloud, and we start collecting that data. Now, the agent that I talked about that's on that sensor node is really just a driver that's capable of using a library that we provide to define, what data it's going to send to the cloud, how often it's going to send that, and what data it expects back from the cloud.
Okay.
Right. So there's no SDK that's required. They basically get a C library, and then that will be utilized with whatever development environment that they're already using for that node. So now we've got data. We've got the we provide a mechanism so that the devices themselves are secure, so that we're basically providing a AAA level of security. So devices authenticate, they get authorized, they're sending data to the cloud, and that data can be audited in terms of who's sending it up. So we know, we know what's talking to us, and at that point we have another library which is provided so that the OEM can create a mobile app so that this data and the sensors that are connected, the hardware that's connected, can be accessed, right? So in the case of the building operator or the building manager, he may get an app that's running on his iPad. This is the utilization of energy in the last day. This is the utilization of the energy graph. In the last day 1 year ago, how's my comparison? Are there any demand management events expected in the next day that I need to be, worried about or at least know about, so that I can answer people when they say, why does the temperature seem a little bit off?
So let me understand this. Who writes the code to communicate with your agent then?
So there's three pieces generally of code that's required. One is, of course, for that end product, whatever that the thing that has the sensors on it or is doing some function, and so that's going to be the expertise of that manufacturer. So there's that piece of code. We can't ignore that. So that piece of code, we provide a library and a driver, if you will, a C driver, which allows that processor to talk to the wireless module and then send whatever data. So they can send, create the data pairs that are required and send the data up to the cloud as required. So what I just talked about was two pieces, right? One was the application, and then one was tying the application to the cloud. Okay. The second piece is we provide a library for creating mobile apps. So the customer may choose to create a web portal, or they more likely now what we find is people want to do native apps, either a native app on an Android or a native app on an iPhone or some mobile device there, where now they can get the results of all the analytics. They can see their nodes or their internet connected sensors and interact with them. And so there we provide everything else in between. We will subcontract and have mobile apps written, but basically we're really just providing a library that any iOS developer can use to create the rich apps. But everything else in the middle we take care of. So the cloud, security, the stacks in terms of sending that data up and storing that data, and then analyzing the data, providing reporting for that data. That is provided as a platform.
Okay, all right. Well, Mark, this has been really helpful. Where can our listeners find out more about Ayla and your company? So
the best place to start is at aylanetworks.com. And let's
AYLA.
I think yes, it's AYLA network.com, and they can find out more information on our platform as a service and our software as a service from that site, and then they can also put in a request for someone to contact them if they are in that stage of architecture where they want to discuss their next product.
And you guys do get involved a little bit on biz dev to kind of talk things over early on, because it seems like you do have a lot of knowledge to share.
Yes, we absolutely do. We can share in terms of what may make sense on the type of product that the customer wants to build, but also the business model. So there's various business models that are available depending on what type of product is being fielded. If it's something that does utilize maybe an ongoing subscription type service, or something that cannot do that, right? So example, something that's more consumer, where people just kind of want to buy it and they want it to work for a certain amount of time.
Great. And do you have a Twitter handle that we could share?
Yes, my Twitter handle is mwright88, and people can.
And I'll put that in the show notes too. All right, Mark. Well, thanks a lot, and we'll be talking soon.
Thank you very much, Bruce. Have a good day.
Okay, that was a detailed talk with Mark Wright. This podcast goes vertical, deep diving into different topics each week. If you prefer a more horizontal and structured approach to learning IoT business and its orbiting technologies, check out my book IoT Inc, published by McGraw-Hill, or become a certified IoT professional by completing the ICIP training and certification program. For details, just go to www.iot-inc.com. Also go to www.iot-inc.com for an analysis of this episode, links to things that were mentioned during the episode, and very importantly, the episode's PDF transcript. Just search for the name of the episode or the guest. If you're new to this podcast, subscribe. That way you'll get every week's episode delivered straight to your device. Or, if you've been listening for a while, there are 3 ways you can support the show. You can leave a rating or a review on iTunes. Just go to iot-inc.com/iTunes. It only takes 1 click to leave a rating, a little bit longer to leave a review. You can share it on social. I'm on LinkedIn, to a lesser extent on Twitter. And of course, you can support this show by buying my book, IoT Inc, or the ICIP training and certification program. It's how I pay the bills. Next week's episode is The Connected Sensor, what it is and how it scales with Mike Farian. Hope you can join me then. I'm your host, Bruce Sinclair. Thank you for listening. Until next week, may your path to IoT business be an unknotted one.
You have been listening to the IoT Inc Business Show.